switch gears to talk about a bug in Mojave. And I will caveat, this is not the most exciting bug, and it's not even, in Apple's opinion, a security bug, and I think I agree with them. But it's kind of sad and bothersome. So we're going to first talk about a little bit of background, and then we're going to show how to trigger this bug, which is very easy to do. And then we're going to dive into reverse engineering the components of the operating system to figure out the reason for this flaw. So the flaw resides in a utility called vmmap. And if we type man vmmap, we can see there's a man page. And it basically says, display the virtual memory regions allocated for a process. And the reason I was interested in vmmap is because I wanted to see what libraries a remote process had loaded. You could imagine a scenario where there's a malicious Chrome extension, perhaps loaded in Chrome. And I want to scan the running instance of the Chrome process to see if there is a specific dilib that's perhaps malicious. And I actually do this in one of my tools, Task Explorer. Let's just pull that up here. And what Task Explorer does, kind of a neat tool, I will put the link in the chat. It's kind of like Activity Monitor on steroids. Can I make this bigger? Awesome. For example, for any given process, it will show you information about the process, whether it's signed or not. And in the bottom window, it has things like the loaded dynamic libraries. Again, this is very useful. You can say things like, show me all the unsigned libraries. And I've actually done this to find other bugs, which talked about in previous live streams. One of the tricks I did was I basically had a bunch of software running, and I said, hey, Task Explorer, show me if the dynamic libraries from this unsigned bundle has ended up in any interesting places, in any interesting processes. And it turned out that there was an Apple signed process that had entitlements that had loaded my dynamic library, which is cool because once you're within the context of a process, you inherit its trust and its entitlements. Entitlements are certain capabilities that Apple assigns to specific processes. So if you get loaded into an entitled process, you can do all sorts of perhaps interesting things. So using Task Explorer, I was able to find that. So before, I believe it was El Capitan, you could, as a process running as root, directly access the memory of another process, for example, to read what libraries were loaded. For a security tool, that was incredibly beneficial. It makes a lot of sense to be able to answer the question, for a given remote process, a browser, an email client, what libraries, what dynamic libraries does it have loaded? This is a very valid question in my opinion. Unfortunately, Apple basically said, okay, we don't think that you should have that capability anymore. And okay, I understand from a security point of view, there are some ways that that could be abused. So what they basically said is, they said, unless you have a certain entitlement, a certain privilege, you cannot access the remote memory, even to read of a remote process to see. So what they did was basically shut down the ability for us or security tools to enumerate loaded dynamic libraries in a remote process. So this kind of broke my tool, and I said, well, I still want this capability. So I said, okay, let me figure out a way where I can do this legitimately that works within Apple's constraint. So enter vmmap. Vmmap dumps the virtual memory of a process. We can show that really quickly in a VM. So if we, for example, open calculator, we can now get the PID of calculator, ps aux grep -i calc. Oops, I need an I. And we can see that calculator has a PID of 714. PID is just a unique identifier for the process. So now we can come over and we can say vmmap, and we just pass it that PID, 714. This is going to run for a second. And we can see now it dumps all the memory regions of the calculator process, which also includes all dynamic libraries. So this is a way for us to kind of indirectly re-enumerate the dynamic libraries that are loaded in any given process. So what we can do is we can look, for example, for text segments. Text segments map to text executable code. So we can see all these different frameworks. the path is truncated just because it's displaying. We don't have to really worry about that too much. So what I do programmatically is invoke the vmmap tool and basically read the output. And then this gives me the ability to enumerate remote dialibs. So all is well, right? And again, the reason we can do this is because vmmap has a special entitlement. So if we come to vmmap and we click signing information, this is one of my other tools. It adds this right-click option to any context menu, kind of a powerful capability. We can see that it has a bunch of entitlements, and it specifically has the task port entitlement. What this entitlement says is this process is allowed to get the task port to remote processes. And once you have this task port, it's kind of like the key to the front door. Once you have that, you can do things like tell me all the memory regions or the dynamic libraries that are loaded. This is a private Apple or an Apple specific entitlement. This is not something third-party security tools can give to themselves. So for example, I can't directly give myself this entitlement and then go enumerate loaded dynamic libraries. But what I can do is I can just execute vmmap and it has the correct permissions. And then I can parse its output to get a list of dynamic libraries. So all was well and good. Task Explorer was happy. It was re-enumerating loaded dynamic libraries. I was finding bugs using this tool. Awesome. And then Mojave came along and Task Explorer crushed the system. And I was like, damn, like, do I have a bug in my code? And I got some nasty for like, your tools suck. And I was like, oh man, gotta dig into this and figure out why. So I looked into my code and I found what was happening is the bug existed when I was invoking the vmmap utility, which was strange. And this was actually kind of good because, again, this meant this wasn't a bug in my code. I was just invoking vmmap. Vmmap is a utility. You're allowed to invoke it all day and night. But somehow in Mojave, there was a new flaw or issue that Apple had introduced that would break the system. And we'll demonstrate this now. So what we're going to do is we're going to execute vmmap as root, vmmap, and we are going to give it, oh, I can't spell, PID1, first PID on the system. Should ask for my password for my VM. I'm going to run this, and in theory, it should start dumping out information about this process. Okay, it's kind of taking some time. Sometimes takes a while on the VM. And I don't know if you can see on my screen, but now my VM is totally hosed. Like, there's the spinning ball of death, but it's not even spinning. Like, it's fully dead. I can't click on anything. It's like totally toast, right? Click on nothing, nothing works, no escape sequence. Like, the system is completely frozen. And this sucks because it's like, well, like, how do you get out of this? And the answer is you have to manually reboot the system, which sucks if you have like text documents open and tabs and incognito windows because you're logged into another GitHub repo because it doesn't support two connections or two users at the same time, blah, 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 blah. So I was kind of like, ugh, thanks Apple. Because again, this wasn't an issue on El Capitan, right? You can run vmmap 1 all day and night, no problem. So obviously this is the bug. This is something that's fully reproducible. So yes, go tell all your friends to run sudo vmmap1. Tell them it's a fix for the FaceTime audio bug, because it is. I mean, it'll crush the system, so then no one's spying on you, right? I was so tempted to post that, but I didn't. Okay, so now let's dig into why this vulnerability occurs. That is to say, why when we try to dump the memory permissions, the memory pages of PID1, why does the system grind to a halt? And why does this command literally crush the system and force us to do a reboot? So we're going to do some reverse engineering here. And this will ultimately allow us to answer that question. So first, what is PID1? Good question. So we can run PS, which lists processes. And I think if we do grep1, this might match on everything, but we should eventually be able to see a PID with, sorry, a process with PID1 somewhere. Are these going up? So we should go down. Okay, cool, right here, boom. Make this a little bigger. So we execute vmmap and you give it the PID of the process that you want to dump the memory map of. In our scenario, we were doing that because we wanted to get the list of loaded libraries in the remote process. And we're running as root, so there's not a permission issue here. PID1 we could see is sbin.launched. Launched is an important process. It's kind of like the arbiter or the grandfather of every process. For example, if we execute calculator open, I think we just do, let's see, applications, calculator, cool. And then if we open, I think, activity monitor. If I had Task Explorer, we could do this too, but I don't have it on this box. I know, it's a shame. I should be better prepared. If we switch to processes hierarchically, we can see that other than kernel task, and we'll get to that in a second, every process eventually executes up to launched. Well, saying that in a better way, launched is the ancestor for every single process. So even calculator, which we executed, which is down here somewhere, a little hard to see, but it is under, I just clicked on it, whatever. It is under launched. So this means launched is the parent, the grandparent, the great-great-grandparent. It is the ancestor of every process. And it's actually executed directly by kernel task being the actual kernel, running in ring 0, the brain of the system. So launched is the first process that gets executed in user mode, and it's directly executed by the kernel. So it's kind of a special process. So in some ways, it's not too surprising that if there is a bug in vmmap, it's kind of triggered when we're actually trying to examine launched. So now we know what we now know what PID1 is, and launched is always going to have PID1 because it's the first process that's executed on the system. So now let's take a peek into vmmap to basically try to figure out what it's doing. I told you vmmap dumps the memory regions of remote processes. So I did some prerequisite work on this because it takes me a while to figure out these things, and you guys probably don't want to see me flailing. So one of the things that vmmap invokes before executing the code to dump the actual memory is something called task start peaking. And I'll copy and paste this code again. Hopper, which is the disassembler I use, doesn't nicely show or doesn't nicely enlarge text. So looking at this name, you're like, okay, this name kind of makes sense. Before vmmap starts dumping memories, it might peek at the process to make sure it's running or it's in a state where it can dump the memory. Who knows? What we're going to do, though, is we're going to set a breakpoint on vmmap and then see how things go from here. So we hop back to our VM. We're going to use LLDB. LLDB is Apple's or macOS's debugger. And what a debugger allows us to is examine other processes and step through them. So we say LLDB vmmap. Oh, I think we have to run this as sudo, actually. Let me just kill this. Because we're dumping the memory of a process that's running as root, which means you yourself have to be running as root. Ugh, too many passwords. Okay, now we have to set the command line arguments. I don't actually know how to do this. I Google this every single time. LLDB, you can see, set command line arguments. You can see I've clicked on this before. Something like process. You know what? There's a Stack Overflow. I should just bookmark this. Okay. You say settings, set target, run args. Yeah, that's pretty easy to remember, right? So we're going to set it to 1 because vmmap we're executing with 1. That's the PID of launched, whose memory we're trying to dump. Once we do that, we set a breakpoint on this task start peak method. So I think we can just say B breakpoint on that. If all works well, when we hit continue, it'll hit this breakpoint. We type R for run, and we see that the tool vmmap is executed until it executes that that function which we just set a breakpoint on. So again, we did that via typing b and then the name of the function. This tells the debugger, put a breakpoint, a stop on this function, and as soon as the code executes that, pause, break. We can still see the VM is fully functional, so now we know that no code before this has triggered the issue. So everything is good. The VM hasn't crashed, macOS is running, everything is happening. If we do BT, I think it's BT, we can see a backtrace. And this shows us what called into this task start peaking. So we can see vmmap has some unnamed symbols. We actually don't really care what these functions are, but this shows us that vmmap has called into this task start peaking function, and the name in front of this indicates the library that it's in. So we can see it's in the symbolication library. If we type image list, this will give us a list of the dynamic libraries that are loaded in the remote process. The debugger is able to do this, and since we're debugging vmmap, we can see what libraries vmmap has loaded. So these are vmmap's loaded libraries. These are not launchd's loaded libraries. So we do a control F for find, and we type symbolication. And we see there's one called core symbolication, and then another framework called symbolication. This is a private framework. So what we can do is we can hop over to the disassembler, and we can now load that in the disassembler. And I've already done that just to save some time. And we can see here is the code. I'll copy and paste this into a window so we can all see this better. This is the code that implements the task start peaking function. To reiterate, vmmap has called this method, this function. We've broken at this function in the debugger, and the VM is still happily running. So we haven't broken anything. If we look at the disassembly for this, we can see it calls task suspend. This is very important, and this is ultimately the crux of the bug. So what does task suspend do? Well, via its name, we can assume that it's going to suspend the task. So we can come over here and we can look up task suspend in a browser. And it's documented, and we can see that what it does is it stops all threads in the task. So what we can surmise at this point is that before vmmap remotely dumps the memory of a remote process, it suspends that process. And that's important because otherwise, if you're enumerating remote memory and something changes, you might cause all sorts of issues. Now, in theory, this is fine. You should be able to suspend launchd, dump the memory, and resume it, and everything should be okay. And we can actually see that vmmap does this, I believe. So if we come over here back to the debugger and put a breakpoint on task resume, I haven't actually tried this, so we'll see if I eat my words. B. Okay. If we hit continue, let me move this up a little so we can see all of this. Okay, we call start peaking again. Okay, we call task resume. So that's good, right? That means that, yes, vmmap is suspending the process it's about to dump the remote memory of, which actually is a good thing. And when it's done, it calls resume. So in theory, there should be no issue here, right? Launchd should be happily running again. All is good. So we have to dig more. And we do that by looking at the core symbolic framework, which is another library that vmmap calls into. And specifically, it invokes something. Again, I'll cut and paste this so we can, I'm going to just message the Hopper peeps sometime and say, hey guys, can you make this? So when I increase the text, I can do Command plus and it makes things bigger. So another function that, I'll make this easier to read, vmmap calls is the mmmap storage daemon v. I have no idea what this function does. It doesn't actually matter. What's important though is it gets called. So we can come back to the debugger and we can set a breakpoint on that method. Geez. It might be an unknown method, so we might actually have to set a breakpoint on the memory address. What did I do? Oh, this. So this is loaded. Oh, and this is kind of cool. So this is a neat little trick. So we're looking for the address of storage daemon v because we need the address in order to set a breakpoint on this. Now, if we look at the address here at 00000 something 6F6DE, what happens in a process when a library gets loaded, because of ASLR, it gets loaded at a random address. So if we type image list, we will see that core symbolication is loaded at 7FF4183B00, some random address. What we can do though is we can copy that and then we come back to Hopper and we tell Hopper to rebase the library so it matches that address so that all the addresses then correspond. So this is kind of a neat trick. So you click on modify, change file base address, and paste the, oh man, I just hit Control V instead of Control C, the address into this window. Oh my goodness, does copy and paste not work from this VM? Come on. Oh. No, because VM is launch D is paused. All right, well, I could write this down and do this, but you're just gonna have to trust me on this. So I'm gonna revert this VM once more because I have paused vmmap and launch D just too many times, thereby re-triggering the bug. But while this VM is restoring, we can come back to Hopper, and as I mentioned, it invokes this method. If we look at what this method invokes, it calls something that's CSP daemon connection. This doesn't really matter. This calls some other method, and then we get to this chunk of code here, which is why the system goes to hell. So if we look through this is code that vmmap is executing. It calls something that says XPC connection create mock services com.apple.core symbolication D. So what it's trying to do, it's trying to resolve a service. You can think of this kind of like an address or a socket. XPC, it's an inter-process communication mechanism. And what it's doing is it's looking up the address and creating a connection to this. The idea is once it has access to this core symbolication daemon, it can use it to symbolicate the memory dump that it's about to create. So this is all well and good. The issue is that who do you think resolves these names to XPC services? Anybody have a guess? What process do you think resolves XPC names? And while you are thinking about that, we'll just make sure this VM is happily restored. So here's a hint. There's some process on the system. Yes, good guess. So Namrak guessed launch D. And that's an excellent guess, not just because we're talking about it, but because launch D is kind of this arbiter process. It has the high level of the system. So it makes sense that it's going to be doing things like name resolution. Now, why do you think that this is a problem? So that's correct. It's launch D. Why is this an issue? Specifically, that vmmap is calling into launch D indirectly. So the question again is, why do we think it's a problem that vmmap is invoking this method, which in turn is going to go and make a connection to launch D? While you're thinking about that, I'm going to set these command line arguments again. Like I said, I never remember them. So a hint is, what state is launch D in? So remember we said that before vmmap dumps the memory regions, it calls a certain method that does something to the process. Vmmap calls before, and this took me a while to wrap my head around, so Exactly. Again, Namrak with the win. I wonder if he works at Apple. Basically says that vmmap has halted the process, which it did. It called task suspend, which again is the right thing to do. You want to suspend this process before you start reading its remote memory. But if you have suspended a process and then you go to make another request to that process, that process is never going to be answered. It's like if you are calling somebody's phone and you make the phone busy, and then subsequently you go and you make another call to that same number, it's still going to be busy. So the issue is vmmap has suspended launchd. It then tries to do this symbolication. Under the hood, symbolication tries to resolve an XPC address, which makes a call to launchd. Launchd is now halted, though, so it will never answer that request. vmmap is just waiting, sitting for that response to be answered. It is never answered. And this is hugely problematic because launchd is then now suspended. And launchd is, again, this arbiter process. You can think of it as the user mode brain of the system. So if it remains suspended, the entire system is just, pardon my French. Well, we won't say this. It's screwed, right? It's just hosed. So problematic. So we can see this in action by setting, we'll just execute this again, right? Sudo vmmap1. Put in the password for the VM. If I can type it correctly. So vmmap has suspended launchd. It then says, I'm going to start dumping the memory, which it does. It then says, I want to symbolicate this memory, which just basically means instead of memory addresses, I want to show you, more readable names. So it calls into the core symbolication logic. Under the hood, we can see that calls this XPC connection create mock service message. This is handled traditionally by launchd. Launchd is suspended, so everything is just, I really want to say the F word, but this is going to go on YouTube later. So the system is just toast. So this isn't a security bug per se, but this is kind of problematic. And I'm really not going to go on a rant here to knock Apple and their Q&A process, but this is really frustrating, not only because this is just a lame bug that should have never made it through Q&A testing, but again, the reason we're using or forced to use vmmap to examine remote processes, excuse me, is because Apple has told us that as security researchers and writing third-party security tools, we cannot examine the remote process of other memories. So they basically say, okay, you have to use vmmap, which I said, okay, I'll use it, but then it has this horrible bug in it, which just crushes the system. Less than good. Exactly. So I have some notes about this bug that we will just go through. This is actually my bug report I submitted to Apple because I'm generally somewhat responsible. So this will just reiterate what we just saw. On Mojave, due to a logic flaw, vmmap1 causes the entire system to die a horrible death. That's a good way of putting it. So there's the bug report. A little bit of background, as we mentioned, Apple prevents processes, even security tools, from directly enumerating dynamic libraries that are loaded in remote processes. This is an important thing to do. You want to be able to scan remote processes to see if there's a dynamic library that's loaded, etc., etc. Because of this, because Apple has basically told everyone to GTFO, we're stuck using Apple's tools, for example, vmmap. And vmmap's fine, we can do that. That's not the end of the world. Kind of sucks, but it's still an option. Again, this works because Apple has given vmmap these certain entitlements, which says they are allowed to still examine the remote process memory. In 10.14, Apple introduced a bug. Whereas if we execute vmmap against PID1, this will cause the entire system to hang. So the repo steps are very easy. You just run vmmap1 as root. This will, as we noted, call task suspend. This will suspend launchd. Then while the task is still suspended, and this is important, vmmap calls into the core symbolication library, which in turn calls this storage daemon function. I have no idea what this function does, but the important note is it tries to resolve an XBC endpoint, which is normally handled by launchd. As launchd is suspended, this XBC lookup fails, and the entire system grinds to a halt. Right? vmmap is waiting for launchd to come back. Launchd is never going to get resumed because vmmap is only going to resume it once it gets the response back. But since launchd is halted, it's essentially dead or suspended, that response never comes. And while the rest of the system is doing its thing, if launchd is suspended, because it's this arbiter of everything, it's kind of like, if your head was suspended, if somehow your brain got suspended and you were walking, like you would walk into a tree and die or off a cliff. So it's kind of interesting for a few things. One, this was introduced in macOS. So if you run vmmap 1 on any older version of macOS, it's fine. So as a security researcher, I always worry that I'm going to run out of bugs to talk about, but new bugs are always introduced. So I'm going to say this with a wry grin on my face, but thank you to Apple for continually adding new code. And this is a plea kind of to Apple, and I don't mean this in a negative way, but if you're not going to provide an API for trusted security tools that are running with root privileges to enumerate loaded dynamic libraries in remote processes, for example, to scan for malware, you basically force us to use your tools. And so if that's the case, please ensure that these tools actually work. Like, it's really not fair to us as security researchers and people who are writing tools to protect Mac users if you are going to give us tools that have bugs that when we execute them, freeze and crash the entire system. Like, that's really not cool. So go ahead, Apple. You really can't, in my opinion, have your cake and eat it too. You can tell us not to do this ourselves and give us tools, but then please, please test these tools. So I noticed, as I noted, I reported this to Apple a while ago. They did not classify it as a security issue, which I think I agree. It's really a massive annoyance. I mean, you can cause the system to die a horrible death. But from my point of view, agreeing with Apple here, there's no security repercussions here. It is annoying because they haven't fixed this yet. But maybe if I talk about it, they eventually will. And my hope is they eventually do fix this, because this is a bug in one of their core system utilities that, you should think it would function, right? It's written by them. Kind of annoying. So at least I can go back to the users who told me my tool sucked and be like, you have a fair point. I should also test my tools more, especially on newer versions of OS. But, I'm an army of one. Apple is, an army of many. And in my opinion, if they are introducing bugs, the onus is on them. My personal opinion. So then, so that's the wrap. This is the issue. Go tell all your friends to run. This VM's dead. Go tell all your friends to run vmmap 1, and forces them to then have to hard reboot the system. I don't even think you can remotely SSH in, because launchd is really monitoring and controlling everything. So I've tried it where I've had 2 terminal windows open, and I jump into the other terminal window and try to resume launchd, but it always fails. So it's once this command is executed, the entire system is going to die, forcing you to have to reboot.